Hello, my name is Michael Witten. This is the Advanced Data Management D191 assessment video. Before we get started, I want to just quickly talk about the the coding environment here that we're working in. This is PG Admin. It's on a virtual machine provided through WGU. There are a couple databases here that we're working with. We're working with the DVD rental database. There are multiple, the schemas here have multiple tables, and we chose to focus on the rental table and the customer table. It's a bit of a challenging environment to code in, and so along with that that particular environment, I decided to use C++ editor as well, so that I could save my work as I went along, and that way every hour or whatever the environment chooses to shut down, I can retrieve my code. So I was able to work through those issues. Let's go ahead and get into it. Part A was just a summary, and it's included in the PDF that I have attached along with this video. The summary is just stating what we're doing here in the tables. The business concept is just to measure the engagement we're having with clients in the video rental business. Simply, we want to know how many people are coming in and how many people are coming back and how many people are coming back emphatically. So how many customers do we have and how many unique customers do we have? And that should let us know whether we're treating our customers correctly, whether we need to focus more on retention, or whether we have really good retention, we need to focus more on getting more customers into the store. So I'll let you read the PDF for the details there, and I'll just go over the the code now. I am going to make sure that I didn't leave any of these tables open. The drop tables, or the drop statements, were meant just so that I could test everything. So let's get back to the code. We're going to start with Part B. Part B is write an SQL code that creates tables. So that starts on line 8. The create table had my first table was engagement detail. It's about customer engagement, so super creative of me. Engagement detail table contains customer ID, a rental ID, customer name, email, and the month, rental month. And the next table that I created was the summary table, which I just named engagement, which only includes the total customers and the unique customers. So I'm going to go ahead and create this tables now, highlighting create table for the detail table. And it created successfully. And now creating the summary table, and it also created successfully. We'll go down to Part C. Write an SQL query that will extract the raw data needed to fill the detail table. Here's the insert statement beginning on line 23. The select statement includes Part D, which are the functions that perform transformations, and I'll point those out now. Concatenation of first and last name as customer name is what I'm highlighting now. So that is the first transformation, and then the second transformation was the extract the month from the rental date. The rental date was actually a timestamp which had the year and time of each rental, and for our purposes we just needed to know what month it was. So the purpose for both of those things was readability for the end user. The The parameters we wanted the customer ID for the rental to match the customer ID for the customer. And we've just picked a random month, 6. On that note, if this were a current database, we could use the the current timestamp to get this month's data, but because it's an old database, we had to pick a month, and I just picked 6 for no particular reason. So that was part C, write an SQL query to extract the raw data, and part D, write code functions that perform transformations identified earlier in part A. The second part of C was to verify the data's accuracy. In order to do that, I decided to write 2 checks. The first one is simply a check to make sure that the data was inserted into the table, and I ordered it by customer ID and rental ID, so I'm going to go ahead and run that now. Oh, you know what? I didn't actually run my insert statement, so I'm going to go ahead and do that first. Great. All right, so back to the check, select all from the detail table, sorted by customer ID and rental ID. You can see that we have customers that are coming in multiple times. Sharon Robinson came in 3 times, and Lorraine Little came in twice, and so we have multiple rental IDs per every customer ID, and that's, I think in business you would want to see that. It means you have customer retention, people are coming back and using the data. But for our purposes of this check statement, we wanted to make sure that the data populated and that we don't have any repetitive rental IDs inside of a customer ID. So that was what that check was, just to make sure that it populated and you didn't have any obvious problems there. The second check was to check for data integrity. And so what I did was I wrote a statement where the parameters were that the customer ID is null, or rental ID is null, or the rental month was not 6, which is the month that we chose. And the idea is customer ID is not allowed to be null, rental ID is not allowed to be null, and rental month is not allowed to be anything but 6. So if anything is returned by this query, then there's a problem. We're hoping that no rows are returned. So I'll go ahead and run this, and there's nothing returned. So that's a good check. It doesn't mean that everything's perfect, but it does mean that data is at least valid. The next thing that I did was I skipped ahead to part F to create a stored procedure. I did that because of a video that I watched from one of the WGU professors here that worked backwards from the procedure to the trigger, and so I followed his method to do that. The stored procedure is named update table, and it begins with what is required. The statement F says, create a stored procedure that can be used to refresh data in both your detailed and summary tables. The procedure should clear the contents of the detailed and the summary tables. So to clear the contents of the tables, I use the truncate engagement detail, that's a detail table, and truncate engagement, which is a summary table, and then to refresh the data, there's an identical insert statement into engagement detail, and then the summary statement had a new insert statement, insert into engagement, because it's trying to find how many total customers there are. We're simply counting the number of rows, count customer ID as total customers, and then because we want to know how many unique customers there are, we were going to count the distinct customer IDs as unique customers, and that's how we came up with those numbers. And that is that. So I'm going to go ahead and create this function, or this stored procedure rather. And it created successfully. All right, the next function I think is part of item E, creating a trigger. This is the trigger function that calls the procedure. So create or replace a function. You named it trigger function because I'm super creative, and its only job is to call the stored procedure above, which is called update table. So I'm going to go ahead and highlight this and create my trigger function, and it created successfully. And so I'll go down to create the trigger, which is item E in the rubric. Write an SQL code that creates a trigger on the detailed table of the report that will continually update the summary table as data is added into the detail table. I chose to create the trigger to continually update both the detail and the summary table every time a new row is inserted on the rental table. We created this trigger called new rental. Every time there's a new rental, because it's a sales figure, you insert a row, you don't usually need to update that row. So even if you did, the following sale would keep that table updated. So the trigger is here, so I'll go ahead and run it, create the trigger. It ran successfully, and now we'll go ahead and test the trigger and make sure that it works. So what I'm going to do is I'm going to insert a value into the rentals table. This is just a made-up value, and I'll insert that in. Oh, looks like I've already ran that number. I'll just change the customer ID real quick, and then I'll run it again. There we go. So that should have set off the trigger, and we'll make sure that both of our tables are working. We want to make sure that our detail table is populated. It is populated, right? And now we want to make sure that our summary table is populated as well. Looks like we have 2317 total customers and 590 unique customers. I have to run it one more time to make sure that the trigger actually did its job. So I'm going to go ahead and change the ID again. And I'm just changing the rental ID number and the customer ID number so that I don't get in any problems with primary and foreign keys. So I'm going to run this again. Notice that we have 2317 and 590. We're expecting that one of those numbers will change by 1 in a positive direction. So there we go. We'll select the summary table again. And as you can see, it's 2318 now and 590. So the trigger is working, and that's good. The only thing left to discuss was the second part of part F during the stored procedure, which mentioned that we should explain how often the code needed to be updated. It's meant to be a monthly code. You look at the month in arrears, you find out how much your customer engagement was. And that's how the table was meant to be used. So it needs to be updated monthly. Although the way that it's written, the trigger should update it in real time every time there's a sale, so it shouldn't ever be out of date. That being said, if we wanted to update on a schedule, we could use an external tool like Linnet's cron tab. which has the ability to schedule procedures on a hourly, weekly, monthly basis. So I went ahead and made a quick statement about that in the PDF. And I believe that is the end of this video. So thank you so much for watching, and have a nice day.